And moving on to the next one, Dana Hurley. Take it away, Dana.
All right, can you hear me?
Yep.
Okay, great, thanks. Next slide, please. So what I want to talk about is what we already know about the distribution of water ice in the polar regions of the moon and a lot of the stuff that Kevin was just referring to. So I'm gonna, very quickly go through the data that we have and talk about what it tells us about where water is. So in terms of knowing the distribution with depth, there are really three sources of information here. There's neutrons, there's radar, and then there's the L-cross experiment. So neutrons can tell us the amount of hydrogen. It doesn't tell us what form that hydrogen's in, but we assume it's in water. And it's the amount of hydrogen that's distributed within that top meter of regolith. The footprint of these measurements from orbit is pretty large. So we're getting a very large area of volumetric measure of hydrogen, presumably in the form of water. Now, these neutron data also seem to indicate that there's some layer of dry overburden, but we could have large volumes of up to 2% of water equivalent hydrogen there. So with radar, as Kevin mentioned on Mercury, the radar evidence is striking. On Moon, it's not so much. So what that tells us is that we don't have skating rinks of water on the Moon, because in order to show up in the radar, you need to have kind of ice blocks that are fairly pure on scales of 10 centimeters or greater. So the radar data are also tricky. They're not a unique interpretation, but we definitely, it can give a lot of supporting evidence. Now, from L-cross, we know that there is water ice in Cabeus. We saw it. L-cross excavated up to about 3 meters depth, and there was water ice in the ejecta. So, it shows that there is water somewhere in that top 3 meters in this location. Very likely there was ice-coated grains due to some analysis that Jen Heldman did on the evolution of the light curve there. So next slide, please. So then there is also some data about water on the very, very surface, the just extreme coating frost. And these data from for far ultraviolet, from laser reflectance and infrared spectra show that there's a very heterogeneous distribution of water on the surface. And the concentrations can vary up to about 30%, but that's most of the other things are lower concentrations down in the single digits. Next slide, please. So we know from modeling that impact gardening modifies the distribution of any ice layer. You get impacts that churn the material over, and so any ice layer gets broken up over time. There are also thermal processes that act on a faster time scale than the impact gardening. You can have a region that's in like the Goldilocks zone that can pump water down to a depth, but thermal stability is really important. Next slide, please. So, the main takeaway is that we know that there's a heterogeneous distribution of water ice, and that we don't know a whole lot about what's below 1 meter depth. So that's something to consider for the future.
Thanks very much, Dana.